right, my friends, let's see how it went. So there's so many ways to do these and do them correctly. Even, there are many paths you could take and still be technically following the Gaussian method. So for me, what I do is I always just kind of survey the X's, the Y's, and the Z's, and kind of ask myself, like, what looks like the least amount of work if I'm going to be using elimination, knowing that when I pick a variable, I have to figure out a way to eliminate it twice, and I have to involve all three equations at some point. Okay, so for that reason, I personally would strategically go for eliminating X's, just because it looks like the least amount of work. So with that said, let me get started on that. So I would just do maybe the opposite of row 1. So that would be negative 2x minus y minus 3z equals negative 1. And then I'm just going to add it to row 2 there. And just row 2 copied as is. There we go. And then let's just add them up. So we'd end up with 0 x's, which was the plan, and then 5y plus 5z, it looks like, and then we've got that set equal to 2. Okay. Now, keep in mind at this point I've involved row 1 and row 2, and so I need to involve row 3. Otherwise, I won't be solving for this intersection between 3 planes. Like, you could just be stuck with 2 if you don't involve all 3. So. And I also need to eliminate x again. And you could use whatever combination makes the most sense to you. So for me, I think if I think ahead about keeping numbers small and stuff like that, I kind of like combining row 2 and row 3. So I'm going to do negative 3 times row 2. And then I'm just going to add it to row 3 as is. So just copying row 3. Okay, now let's add them together. We get 0 x's, which was on purpose. We get negative 10 y's. It looks like we would get negative 6z equals negative 4. And then notice that this equation could easily be reduced by a factor of 2 just by multiplying both sides by 1/2. And so this is equivalent to, actually, let's get rid of the negativity as well. Let's multiply both sides by, actually, no, I like the negativity. Never mind. All right, multiply both sides by positive 1/2, and we'd get negative 5y minus 3z equals negative 2. There we go. Okay, and so now we have a new system of equations. It's just, these, and you could copy it again or not. It's up to you. So I'll just go ahead and copy it. And since we eliminated the same variable both times, we have a system of equations with the same 2 letters. So that's handy. Anyway, now maybe you can see why I wanted to keep the negativity, because now I'll just have to do is just add the 2 equations together. So I'm just going to say equation 1 plus equation 2. And no reason to rewrite them, since it's really easy to just add them as is. So I'd end up with 2z equals 0, which means I'd end up with z equaling 0. Yeah, great. Okay, so now I know the z coordinate. Now I could back substitute anywhere that makes sense to me to get the y coordinate. So I'm going to go back to equation 1 here. Just looks like the cleanest way to go. So I'd have 5y plus 5 times z, which is 0, equals 2. And then you just have 5y equals 2, which means y would equal 2/5. That's kind of answer that makes you doubt your math, but I've done this one twice, and I'm pretty sure the answer is 2/5 for that. Anyway, so don't freak out if you get some fractions every once in a while. Anyway, and then let's back substitute these 2 values back into one of the first 3 equations. It doesn't matter which one. I like row 1 because the numbers are smallest. So we'd have 2x plus y, which is 2/5, plus 3 times z, which is 0. And then just solve that. So, so let's see, we'd have 2x. We could subtract that 2/5 over, and 1 is like 5/5, so we'd have 3/5. And then divide both sides by 2 or multiply both sides by 1/2, however you want to think about that. And we'd end up with 3/10, I think. There we go. So you had 3 planes, and they all, the one point where all 3 intersect is the point 3/10, 2/5, and 0. There we go. And then if you ever, get the heebie-jeebies, you could always, check your answer in one or all of the equations. I'm just going to go ahead and check it in row 3 here. I wouldn't use row 1 because that's where I got the last answer. So let's see if it works in row 3. So we'd have 6 times 3/10 plus 8 times 2/5 plus 18 times 0, and it's supposed to equal 5. All right, so let's multiply 6 times 3/10. We'd end up with 9/5. 8 times 2/5 is 16/5. 18 times 0 is just 0, and supposedly this is going to equal 5. So 19 plus 16 is totally 25, and 25 divided by 5 is absolutely 5. There we go. If you're going to be thorough, you should also check it in row 2 and row 1. So I'm just going to be a little bit of a cheapskate on that one. Okay, so that's a little practice, my friends, with a single solution problem. And geometrically, that just means you had 3 planes in 3D space, and they all came together and had exactly 1 point in common between all 3 planes. Okay, so let's look at part B here. Part B is going to be an example of a no solution problem. Over here with this picture, you can see kind of an example of what it could look like if you had 3 planes in 3D space, but there's no point where all 3 of them intersect. This is not the only way that could look, but it is a way. Another way that you could have a no solution problem, which I don't think this one is like this, but you could just have 3 planes that are all parallel. That's another way to have a no solution problem. So anyway, go ahead and see how part B treats you and see if you can figure out at what point can you tell that this is definitely a no solution problem.